Welcome, my dear student, in our math program for secondary 3. Dear student, today we are taking the second lesson in static. What is title? Moment of the force about a point in 2 dimensions and 3 dimensions. In this lesson, we are taking moment of the force about a point on 2 dimensions. Dear student, what is the meaning of the moment of force? Ability of the force to remove a body about a point. Dear student, look at the moment of the force about a point in 2 dimensions. Moment of a force about a point in 2 dimensions coordinate system. Dear student, the moment of the force is the ability of the force to rotate the body about a point. Look at its symbol moment. Its symbol MO vector. R vector cross F vector. What is the R? Position vector. What is the F? Force or vector of the force. R is the position of the point A lie on the line on action of F with respect to a point O. Look at where is a point O is called center of moment. Look at O, center of the moment. If the force point A, L is the highest from center to line of the action of the force F. The axis of moment is the line which perpendicular on the plane contains the force F and the point O. Remember, dear student, L perpendicular to the line of F. This L perpendicular to the plane which contains the force F and the point O or the center of moment. The moment of force about a point is equals R cross F. What is R? Excellent student. R means position vector of point A. What is F? Yes, force direction. In this case, R F sine theta. Why? By magnitude, the component of F in x-axis, F sine theta. We replace F vector by F sine theta and R vector by R. We multiply R times F sine theta. Why? Because L equals R sine theta. What is the L? The perpendicular. In this case, moment equals LF. Therefore, L equal M over F. Now we are translate to another title. It's called algebraic measure of the moment. If the force F makes the rotation about O, what is the O? Center of moment. In clockwise direction, the algebraic measure of the moment is negative clockwise, but anti-clockwise direction, then algebraic measure of moment is positive direction. Norm of the moment. What is the norm of moment? F times L. F, the force. L is perpendicular from O to action of the line of the force. Number 4, the moment of the force about a point on its line of action equal what? 0. Remember, we find moment of the force about a point on each line of action must be equal 0. Why? Because no are distant. There is no position vector. In this case, r equals 0. R cross f or r times f sine theta in this case equal 0. Number 5, the unit of measure, the norm of moment in Newton meter. What is the N? N is Newton. Force of what? Unit of the force. Meter, unit of the R. Or dyne centimeter. You remember there is relation between Newton and dyne. Kilogram weight meter. We have more units to measure the norm of moment. Newton meter, dyne centimeter, kilogram weight meter. Now we are translate to example. If I, j, k are unit vectors and f equals 3i plus 4j acts as a point negative 1, 3 of a body, find the moment of the force F about the origin point 0, 0. Number B, length of perpendicular from the point O on the line of the action of the force F. Look at solution. Number A, what is the meaning of R? R, position vector from center or from A to origin point. We have 2 points, O and A. R vector equals OA vector equals A minus O vector. What is the coordinate of A? Negative 1, 3. Coordinate of origin point 0, 0. Then when subtract, answer negative 1, 3. Look at what is the rule? Moment of the body on the point center O equal R vector cross F vector. Negative 1, 3 in ordered pair cross 3, 4. We multiply negative 1 times 4 minus 3 times 3 equals negative 13k. After that, the norm of the moment, we find absolute of negative 13 equals 13. What is the length of perpendicular? This rule, equal moment over F. L, length of perpendicular, equal moment over force F. Equals what? 13 over, what is the F? Square root 3 power 2 plus 4 power 2 equals 13 over 5 equals what? 2.6 unit. This norm of the moment equals 13 unit, and the length of perpendicular L equals m over f equals 13 over 5 equals 2.6 unit. Now we are translate to another example. If we have force F equals I minus 2j act as a point 8, 2, 3. Find the moment of the force F about B 2, 1. This number A. Number B, find the length of perpendicular from the point B to the line of the force F. Look at the solution. Dear student, we have R equals BA. What is the meaning of BA? When we find, dear student, when we find the moment about point B, we find the position vector of point B. What is the position vector of point B? Is BA. What is the meaning of BA vector? Equal point A minus point A. By substitution, about point A and point B, subtract A minus B, x from x coordinate, y from y coordinate, to calculate position vector of R. After that, we find the moment equals R vector cross F vector. Look at, dear student, R vector equals what? R vectors equals B A vector A minus B. By substitution, answer is 0, negative 2. Then moment of vector, moment of the force about point B equals R vector cross F vector. 0, 2 ordered pair cross 1, negative 2 equals what? x1 times y2 minus x2 y1. Answer is 2k. y 0 times negative 2, 0 minus negative 2 times 1 equals 2k. This moment of the force at point B. What is the length of perpendicular m over f? Equals 2 over root 5 multiplied by root 5 up and down. Answer is 2 root 5 over 5. Moment principle is very important. Look at, dear student, version theorem. Fermion theorem, what you mean? The moment of the force F with respect to point to a point equals sum of moments of components of this force about the same point. Look at, dear student, if we have force vector, we resolve it about two axes fx and fy. Look at a point OA is our vector in two coordinate or two dimensions x and y. Look at when the force act at a point A, F, we resolve it in two directions or in two dimensions fx and fy. In this case, F equals fxi plus fyj. Act at a point A and its position act a point A. Position vector with respect to the origin point R vector xy. Moment at a point O or origin point equal R vector cross F vector. R vector means point xy. F vector means fx, fy two coordinates. Then by using x multiply fy in k minus y times fx in k vector. This moment fy about O plus moment f of x about origin point. Example. Look at, dear student, in the opposite figure, find algebraic measure of the moment of the force about O. Solution. Look at, dear student, we resolve the force 200 into two x-axis and y-axis. 200 cosine 30 in x-axis, 200 sine 30 in y-axis. We solve the force 200 Newton. F1 200 cosine 30 equals what? By substitution, cosine 30 equals root 3 over 2 multiplied by 200 equals 100 root 3 Newton. F2 equals what? 200 sine theta. Sine 30 equals half. In this case, F2 equals 100 Newton. Moment equals, yes, negative F1 times 2 minus F2 times 1 over 2, or distant half. Look at 2, the intercepted y-axis, 1 over 2 intercepted x-axis. Then by using the previous theorem, moment is negative 100 root 3 times 2, this F1, minus 100 times 1 over 2 is F2. Answer is negative 200 root 3, negative 50 Newton meter. This is the moment of the point A on the origin point. We have solved by other solution. Look at 200 length of perpendicular from O to the line F is called L. L consists of, dear student, OD and DE. What is the length of OD? Look at triangle 30-60 degrees. L opposite angle 60. We find length of OD by using cosine 30 or sine 60. Sine 60 equal L over 2, or cosine 30 equals L over 2. Cosine 30 root 3 over 2. By substitution, we find the value of OD. By the same method, we find DE. Remember, DE in a rectangle, opposite angle 30 degrees, equal half length of the hypotenuse. Then L equals 2 cosine 30 plus 1 over 2 sine 30 equals root 3 plus quarter meter. In this case, we multiply MO equals negative 200 times root 3 plus quarter inside bracket, same answer, negative 200 root 3 negative 50 Newton meter. This is other solution to previous example. Now we are translate to another example. We have force 100 inclined between 100 force and horizontal 40 degrees, length of y 1.4 and the length of x 0.4 meter. To find the moment, algebraic measure of the moment of the force 100 Newton about the point A. Remark, dear student, resolve 100 into two axes, 100 cosine 40, 100 sine 40. By multiply 100 sine 40 times 0.4 x-axis plus 100 cosine 40 times 1.4, answer is 132.95 Newton meter. This is the moment of the point O. Theorem. Dear student, the sum of moments set of coplanar forces meet at a point about any point in the space equal the moment of the resultant about the same point. This is important theorem. Look at, we have more forces, F1, F2, F3, and so on, act at one point. Position of the vector A on O, origin point is R. What is the resultant? Sum of moments of all forces F1, F2, F3, and Fn at a point A equals sum of resultant of these forces at this point. Look at moment about point O equals R cross F1 plus R cross F2 plus so on to R cross Fn. By using highest common factor, we write moment equals R cross bracket contains F1 vector plus F2 plus Fn. In this case, this is the theorem equals R cross R resultant vector R capital represent resultant of all forces F1 force plus F2 force plus F3 force plus 2 so on Fn forces. Then we deduce that if we find moment of the forces, many forces about point, we find the moment of resultant of these forces about the same point. Now we are translate to example. F1 force equals I plus 2I, 2J. Second force 1, 3. Third force 4I plus 4J. Act at the point A, negative 2, 1. Remember, we have three forces. F1, F2, F3 act at a point A, negative 2, 1. What is the required? Find the sum of moments of these forces about B, 0, 2, then find the moment of the resultant about B. Remember, in this case, by using the previous rules, we find the moment of all forces equal negative 12 K. The general theorem of moment. What is the general theorem of moment, dear student? The algebraic sum of the moment of set of forces about any point equal the moment of the resultant about the same point. Algebraic sum of the moment of set of forces about any point equal to the moment of resultant about the same point. Remark. We have two remarks very important. If the moment of force about point A equals the moment of the point B, what you deduce? The line of the force parallel to AB line segment. Remember, dear student, if we find two moments about two different points, moment about point A and moment of about point B, and we deduce that, or we know that moment of a point A equals moment of point B, then we deduce that the line of the force parallel to line between A and B. Number two, if we find MA equals negative MB, moment about B equals negative moment about point A. What you deduce? Yes, we deduce that the line of the F bisects AB line segment. Remember, dear student, two remarks are important. When we prove that the line of the force parallel to AB must prove MA equals MB. when the required prove that line of the force bisect AB, we find moment about point A, and we find moment of point B, and we deduce that moment of point A equals addition inverse of what? Yes, equal negative moment at a point B. Now we are translate to example, very important example. In the opposite figure, AB represents a left to left goods. If the tension is in the string 140 Newton, the weight of the box is 125 Newton. Find the sum of moment about the point B. Remember, dear student, we have AC equals by Pythagoras theorem 12 squared plus 9 squared equals 15, length of AC. Then look at when we find sin C by two methods, EB over BC. Sin C equals AD over AC. Then the relation between sin C equals EB over 5 equals 12 over 5. By cross multiplication, we find length of EB equal 4 meter. Moment at a point B equals negative 125. Why negative? Because, yes, clockwise direction, moment 125 Newton act at point B with clockwise must its sign negative 125 multiply 4 plus 140 times 4. Why? Because 144 act in anticlockwise. The answer is 15 Newton meter. Now we are translate to another example. Look at, we have more moment or more figures A, B, C, and D. Number A, the moment equals 0. Number B, moment equals F times L. Number C, in this case, theta equals what? 90 degrees perpendicular. Number C, moment equals FL sine theta, because F inclined by line by angle theta. Theta smaller than 90 degrees. Also D equals moment about point A equal FL sine theta. In this case, theta more than 90 degrees. The figure, the greatest value at A, B, C, D at figure B, where sine theta or sine 90 equals 1. When in CD, sine theta smaller than 1. Dear student, by end of the lesson, I am very happy to spend such time with you. Don't forget, math simple, think, work, produce. Goodbye.